Hey, and we are live. Welcome back, everyone, to another Friday afternoon debate stream. I am joined again by Corey J. Mahler of the Stone Choir podcast, who is going to be having a discussion about evolution with longtime friend of the channel, JF Gariépy. How's it going, Corey? Thanks for being here.
Going well. Thank you for having me back.
And JF, always a pleasure. Looking forward to the debate. I think it's going to be a tough one for Corey. We all know JF has a degree in biology here, so he's going to be bringing the heat. But thanks for being here.
It's a pleasure to be here.
So we'll do this kind of the normal way we've been doing it. We'll have JF start off with sort of his pro-evolution argument, and we'll just go into a back and forth open discussion from there. I'll try to stay out of it. I might jump in if I feel like things are going over too many people's heads. As a midwit, I'm good at gauging that when it's getting away from the audience. So I might jump in and ask for a little better explanation if necessary. But other than that, I'll mostly stay out of it. And as for super chats, we will read those at the end of the show. We should be able to get through all of them. We've been able to the last couple times. Please keep them respectful to the guests. If it's crazy stuff, I might not read it. Consider yourselves forewarned. And with that, I will hand it over to JF to get us started.
All right. So what is evolution? What is science? Let's start with the basics. I don't believe that science orders us to adhere to any moral program. I don't even believe that science imposes itself. You can be deluded. You can refuse to engage with reality. You can choose not to see what's around you. But to me, evolution is an explanation. It's a theory. It's a software of some sort that you can invoke, and that explains extremely well the things that we see. And to an extent, it's, to me, evolution is a IQ test and also a curiosity test into determining, given what you see, are you capable as a human being to repeat, to iterate in your mind and to see what could happen if the reality that we see around us was to be extrapolated over millions or billions of years. And then this is where evolution shines as a better explanation than anything else to explain how did we end up with life on Earth, how did we end up with so much diversity, and why the hell am I the cousin of a bacteria? Why do I share genetic material that resembles that we found in bacteria? So evolution gives the key to understand all of this. It is a realistic hypothesis at first that at this point is so confirmed and accepted that we can basically call it the truth for those who are interested in it. And it starts with the fundamental observation that everything you look around you, there's two types of things. There are things that are alive and complex, and there are things that are not alive and they're not complex. Rocks, meteorites, volcanoes, they are rough things. They don't think, they don't seem to behave in a way as to self-sustain, or if they do so, it seems to be on an accidental basis. Whereas you have these other things, the things that are alive, like mushrooms, plants, bacteria, animals. These things behave differently than the rest of the physical world, and they behave in a self-protective way. And one of the things that no one can help but notice is that they all reproduce. Very importantly, this distinction between the living and the non-living seems to be attached to the fact that we reproduce. The living reproduces. And then comes the question, if you come from two parents who have reproduced, and each of these parents can testify that they came from two parents, and each of these parents can also testify that they came from parents, and that as far as we look into the past, it is a chain of people who are all born from parents that came into existence. And then the question becomes, when did this start? Did this start 6,000 years ago? Did this start 4 million years ago? Or did this start 4 billion years ago? And there are different responses depending on what degree of complexity you want to reach back in the tree of life. But ultimately, you have to, if you want to deny evolution in a serious way, you have to explain to me when is it that this constant chain of heterosexual parents giving birth to children stopped? When is it going back into the past that this started? And if it started at any point, you're going to have to describe that point. To me, it's a little bit like a saved game in a computer game. You can have a saved game that gets you at the very start, and you'll see signs of it. If you start a Mario 64 game at the beginning, you'll see the castle, the explanation of the camera, the explanation of the 3D world, and you'll know that you're at the beginning of a game. But if you load a state game from Mario 64 where you already have 120 stars, where you're pretty advanced, and where you're at the door of the boss Bowser, then you'll know that something has happened before that save state. You'll know that this is a save state of someone who worked his way through the game. The same thing is true of life. We can think of looking into the past as looking into a different save points. And in a way, the life forms that have survived up to now, they all inherit from the characteristics of a saved point, some point in the past. For example, the animals that today are fish, they come from animals that must have been fish, that must have been in water, and that must also have given birth to other life forms that are not fish, like humans. And we share common ancestors with these life forms. At a state at which we inherit certain of their features, we share some of the features with fish. For example, fish have the beginning of limbs in the form of fins. Certain fish are actually capable of walking on sand with their fins. And in our case, we have evolved fins into limbs that allow us to be even better at walking and at becoming terrestrial animals. Now, one of the key features of evolution is natural selection, discovered by Charles Darwin. Charles Darwin had noted, again, this is where evolution is an IQ test. Charles Darwin was very intelligent and looked at what we were doing in the farm, looked at the fact that we were able to select life forms to become something. We were able to make pigs into producing more fat. We were able to make wheat that would produce more calories for our societies. And Charles Darwin realized, well, is a human even necessary to this selection process? What if these life forms were let to be on their own? There would still be a process of selection. It wouldn't be artificial selection. It would be natural selection. That is, unless the number of babies that any life form creates are perfectly equilibrated and everyone has the exact same amount of babies, there will be some people who are more successful genetically than others. Whether there's a human selector or not, that is the great discovery of Charles Darwin, which is that a natural selection process must be going on as long as there's not a perfect equilibrium in the amount of baby making across the population, and therefore there is a direction that life forms take. If for a generation this section of the population makes twice the number of babies of this other population, they represent a bigger portion of the world in the next generation. Extrapolate this over hundreds or millions of generations, and you can have massive differentiation happening between branches of life, some having taken the direction of exploiting one niche, some others having taken the direction of exploiting another. So this leads to the idea that natural selection, common ancestry, these two items combined, explains well how we had a life form that was initially very simple on Earth, that this life form led to different branches, that these branches were selected naturally according to different sorts of pressure and different types of niche that they were exploiting to survive. And if you can believe that your parents came from parents, and if you can believe that your great-grandparents also came from parents, it is not hard to believe that 1 billion years ago, 2 billion years ago, there were a bunch of life forms that were very different from you that were also producing babies. To anyone who contests the theory of evolution, I would ask, can you prove to me that this wasn't happening, that what's happening in front of our eyes in every hospital right now, which is women giving birth to children, that this stopped at some point in the past if I rewind far enough? So those are my statements about evolution, and I can't wait to hear what Mr. Mahler has to say about it.
I have three main problems that I would raise with regard to evolution. Before I get to that, I want to comment on your concluding point there about there being successive generations back through time. Because, of course, we all agree that that's true. The fundamental difference between us is not that one of us denies that and the other affirms it. Rather, I deny that at some point in that chain, the ancestor is a great ape. I won't be pejorative and say a monkey because evolutionists contend we descended from great apes. That's the fundamental difference, is that jump there from one species to another is the contention that evolution makes, and the contention that those of us who do not believe in evolution deny. I don't believe that if you go back far enough, you find us turning into, regressing into, in that direction in time, great apes. And for the starting point, for a Christian, the answer is very easy. Adam and Eve. We have a mother and a father of the human race. But to get to the 3 points that I'd like to raise, there are 3 problems for evolution that evolution simply cannot answer. And any one of the 3 is a sufficient defeat for evolution. And the reason for that is a sort of preface to the problems I'm going to raise. A worldview, to include evolution in this case, is explanatory or not. And it is the explanatory power of the worldview that should be used to conclude whether or not the worldview is itself compelling, which is to say, a worldview that cannot explain the world as we find it should not be considered compelling. But a worldview that can explain the world as we find it should be considered compelling, because a worldview that can explain the world is in agreement with the world, is consonant with the things that we find. That explanatory power is warrant to believe that it is true. But to get on to the 3 problems that I would raise, I will list the problems first, and then we can go into them in some depth as we go along in the discussion. There is what I would ultimately call the consciousness problem. There are different stages for that, starting out with the problem of why is there anything instead of nothing, and then moving up to the hard problem of consciousness through the easy problem and some other things. There's the digital problem, which in short is the problem of information, in particular in the case of evolution being in the form of DNA. We'll ignore all of the other problems there are with the structure, the cell, and things that are inherited not via DNA. We'll focus on DNA because it's easier for most people to understand. But DNA is an alphabet. DNA represents information. The problem with that is that it is not in and of itself information. There is an interpretive step that is necessary because the information represents something, the same as an alphabet, the same as words in a book. They don't mean anything in and of themselves. They mean something because they were defined to have that meaning. And there is a requirement to define that of intelligence, because only intelligence can create that digital relationship, as opposed to what we could call analog. Not technically analog in the traditional sense, but just to draw that distinction between the two. And then the final problem I would raise is related to the digital problem. It's the information problem. There are a number of different ways for this. One is what I sort of got into there with the alphabet. There's the definition problem, which is to say that if you have a representation of information, we're dealing with semiotics, then you have the issue of needing an intelligence to define that relationship between the symbol and what it symbolizes, because it does not do so inherently. And then there is the systemic or the system problem of information, which is essentially that any given system cannot contain the amount of information necessary to define that system. And you can build up from a very simple system with, say, 2 points to something as complex as the universe, which has, I don't remember how many estimated particles, some absolutely astronomical, literally, number. You can't store the amount of information necessary to describe that system in the system itself. And so you need something larger than the system in order for it to be possible to describe the system, which obviously leads to an infinite regress, the infinite regress necessarily leading to the actual infinite, the absolute infinite. For obviously the theist, there's an easy answer. The absolute infinite is God, and so you have a solution to that problem. And then finally, if we have time, depending on where things go, I would want to get into sort of an overall meta question. Why does this matter? From your perspective. From my perspective, obviously, there's a reason it matters. If we are created by God, then we have certain duties to God. There are things God demands of us, things God demands that we not do, etc. There's a reason from my perspective. I would question from an evolutionary perspective, why does any of this matter? Because truth can't really matter from an evolutionary perspective, because truth isn't actually a thing, even in an evolutionary system. And even if it is a thing, if we argue it is, if we say that there's the correspondence theory of truth, and truth is simply a statement that corresponds with reality as it exists, it is utterly unknowable in an evolutionary system because none of our tools are inherently reliable. In a theistic system, we have the guarantee of the reliability of our senses and other things like that because they are founded upon God. So we have that as the basis of the reliability. There's no basis for that in the evolutionary system, because in the evolutionary system, all that matters is passing on your genes. That doesn't have to correspond with truth. In fact, if believing a lie makes you more fit in terms of, say, total fertility, then that lie is better than the truth. There's no reason, there's no warrant to believe anything in the evolutionary system. So that's sort of the overview of what I would like to argue throughout this debate. We could start with the consciousness problem if you'd like to start there. I think it's probably the best place to start. And the steps of that are, why is there something instead of nothing? Why is there life instead of non-life? Why is there intelligence instead of only unintelligent life? There I'm drawing the distinction essentially between animals and plants. And I think we can assume that fungi are not intelligent in the traditional way we'd use the term. And then why is there sentient life, human life, conscious life, self-aware life, versus just animal intelligence, which is a very different thing. Dogs are not self-aware in the same way that a human being is. I don't think that evolution has a way to answer any of those 4 steps. Particularly, it can't answer the ex nihilo question. Why is there something instead of nothing?
That is correct. This last one is correct. Evolution does bring some answers to the question you have. It doesn't bring an answer as to why the universe exists. It is not part of the domain, at least for our current conception of what evolution is. It doesn't seek to address why the universe exists, but in the universe existing, it can very well explain why we build from a bunch of molecules getting together at some point 4 billion years ago up to complex life. Some of the other steps that you challenged, in particular, why is there life? This is one at which evolution is at the border of answering. I would argue that with my book, The Revolutionary Phenotype, we can get a beginning of an answer to this. It seems that life, the principles of natural selection, may be embedded into more than what we call living. It may apply at the quantum level in physics through quantum Darwinism, and perhaps you have the beginning of an explanation there, but I would still say it falls outside of the scope of biology to explain as it stands now. And with the classical question around evolution, evolution does not seek to explain why life exists, but it describes what happens once life exists, once something makes copies of itself. And that is what the standard traditional definition of evolution addresses. Now, why is there sentient life? This evolution could bring us into a solid answer. There is sentient life simply because sentient life was better than non-sentient life. And the reasons for it may be multiple. First, it may have been a shortcut. You mentioned that evolution can lead to a lie. That is absolutely correct. But the lie of consciousness is one of the lies that evolution is capable of. This virtual experience that we are something is something that definitely our genes have benefited from with respect to people who didn't have the same type of consciousness. Now, this could play many roles. First, in having a conception of yourself, you can act better in the world. Perhaps there are cognitive shortcuts that were available to genes, where having a delusion that you are a single being allows you to gather food more efficiently. There are also perhaps social functions to having a conception of self. We have language. As humans, we interact with each other, and our interactions and the rumors that we develop around each other are very important to our social life. We keep talking about other people and about ourselves. And that may have been needed evolutionarily. For example, a female begging for money from her sugar daddy. I was watching TikTok videos earlier today. Perhaps if you have a conception that you are something, that you are someone that matters, perhaps you are better at convincing the delivery of services by sugar daddies across the world, or getting onto a yacht, or whatever it is that they want. So perhaps the delusion of consciousness was necessary. Certainly, it was necessary for our survival and perhaps our social survival. That would be my answer to your question around consciousness.
I think perhaps there is some way in the evolutionary system to answer some of the easy problems, so called, of consciousness. Of course, I'm just referencing Chalmers' division of these. And that would be things like cognitive ability, the information stored in the brain, our attention mechanism, the behavioral control that our self exercises over our instincts and various things like that. Perhaps some of that can be answered by evolution, but the fundamental problem is the hard problem, the subjective experience that we have, the existence of qualia, which is really what I'm saying here in a sort of a longer way. There's no way to explain that in a purely material system because qualia themselves aren't material, which means that something beyond the material exists, which is another argument against evolution because evolution attempts to explain in a purely materialistic way how life came about, how consciousness came about, and all of these things. Most people admit, in particular philosophers are willing to admit, you can't explain the hard problem in a purely materialist system. Yes, there's some attempt to go into the quantum and try to use that, but quite frankly, we have barely any understanding of how any of that functions at this point, so that is incredibly speculative, not only in the hard sciences, but certainly once we import it into the areas where we're dealing in philosophy, which is part of this. We're not just dealing in physics and biology, we're obviously dealing in philosophy as well when we start getting into human consciousness and things like that. I don't see a way for evolution to make that jump. It's the problem of explaining the mind. It's the traditional mind-body problem in philosophy. There's no way in a materialist system to explain the mind. And so if we're trying to explain human life, which I think is really the core of this debate, we're trying to explain why we're here having this debate, how it's possible that we're here having the debate. I don't see a way for evolution to make that jump from the material to what is clearly not just material. You have to have something else present. And so the system itself, the universe, is material. But there's clearly something else going on with us that is not just material. We have subjective experiences that are beyond the material, that are not just material. So one of the most common examples used is I have an experience of the color red. That's not purely material. And there are many philosophical experiments demonstrating that fact. You have an experience of red. I happen to not be one of those people who thinks that our experiences are particularly different because they are obviously based in a biological system. They're based in the rods and the cones and the eyes and things like that. And so I think our experience of red is probably pretty comparable. But we have that subjective experience. That's something that's not purely material. And so from the evolutionary perspective, that jump is essentially impossible. And just a quick comment from earlier that came to mind You mentioned the sort of simplicity versus complexity of life. I would just say, as an aside, physicists would probably disagree with non-living things being simple, considering you start out, I mean, we could start really any level, but you have molecules, and you have atoms, and you have down into the nucleus, you're dealing with protons and electrons and neutrons. And then from there, you're dealing with quarks. These systems are incredibly complex, even at that level. The sheer complexity of the universe, up and down, there is no point at which anything is simple. And that is certainly true for life, because what is the simplest thing we could possibly call life? Maybe a 2000, give or take, genome virus, right? That it meets the definition you gave. Basically, it reproduces itself. That's sort of the line. I know that biologists don't all agree that viruses are alive. Many say they aren't.
They're wrong.
I don't think they're really alive. I happen to fall
I
on
think
that
they
side
are
of it.
alive.
You think they are alive?
Oh,
Well, if you think
yes.
they're alive, then it's the simplest possible life because it replicates itself, and the simplest one is about 2,000 base pairs. That's not simple.
Yeah, exactly.
A string of 2,000 characters from a 4-character alphabet. If we get into the math at this point, I was intending to do that later, but that's sort of in the digital problem, the second point that I raised. That is an astronomical number. It is a number that is so large that it is effectively infinite. You can't get there. You can't create that with random chance. I know that biologists and evolutionists always object when anyone says random chance, but the problem is random chance is a fundamental part of evolution because random chance is the thing against which the selection process operates because the mutations are random. You can't have anything against which to select unless you have that random chance mutation. And so the system inherently, foundationally relies on random chance. And if we get into the math, the numbers just don't work because we're dealing with numbers. We don't even have words for these because they are so incomprehensibly large. They don't occur. They can't occur. They won't occur in nature. And
Well,
I'll let you
let's
respond
not
to that
stack
before I
too
give a
many
quick
points
rundown.
because you've been stacking a lot and I have to remember them and run back to them. But for this last point, I would dismiss it simply because you are talking about the space of possibilities of 2,000 flip switches with 4 states each. If you can acknowledge that it would be possible to throw 2,000 die onto the floor, you acknowledge that 2,000 different items picked from a group of 6 is possible, and therefore even easier picked from a group of 4. Now, the reality of evolution is that it's not just throwing die onto the floor, it's filtering those die and carrying them into a next stage and reshuffling them and rethrowing them according to a search and evaluate algorithm that includes natural selection, which is a very important filter. So to say that life is based on randomness is just to tell half of the story, and in fact the least important half. In a way, what matters in evolution and what leads to the process of life to differentiate from everything else in physics is natural selection. Now, going back to the hard problem of consciousness, because I want to get this resolved before we move on to digital and symbolic questions. We need to develop 2 different threads here, the philosophical one and the evolutionary one. Whether the hard problem of consciousness is solvable is a philosophical question. And the fact that we have feelings and we have qualia does not make evolution incapable of explaining qualia simply because evolution is a physicalist-based belief. Here's the thing. You can simply invoke the possibility that having qualia gave advantage to a certain number of life forms over life forms that didn't have qualia. You don't even need to understand what qualia is. You don't even need to know how would I give qualia to Grok or to ChatGPT. You can really just invoke a principle of evolution that is natural selection, and it's really not hard to find reasons why being conscious would be better than not being conscious. So as far as the explanatory power of the standard of evolution, we meet it here. We meet it even if we haven't solved the hard problem of consciousness. Now, to engage a little bit on the philosophical side too, I don't believe that the hard problem of consciousness is properly formulated, and I don't believe that it is a problem. I believe that hidden within this supposed paradox is the problem that Chalmers Chalmers expects a qualia response to a problem that he is approaching scientifically. So, in other words, he expects to feel consciousness and to be able to feel consciousness by looking at a network of connected electronics or looking at some emulator that's trying to emulate brain consciousness. I believe that it is demanding basically from science something that it cannot provide, which is a feeling. Chalmers wants to create a computer network that would emulate human consciousness and tells you you won't ever feel that this network, you won't ever acknowledge or feel or want to empathize with this network. But science is not meant to feel, nor is it meant to acknowledge. Science is a proceeding of empiricism that seeks to develop theories and predictions about the world. Now, here's a couple of things that science can tell you about consciousness. We can note that consciousness doesn't arise out of nowhere. We need a baby. That baby needs to grow. That baby needs to have a brain. We also know that if we intervene in the brain, we can knock down certain elements of consciousness. There are certain psychiatric disorders where damage in specific areas of the brain will lead you to completely not feel your left part of your visual field, and sometimes not feel anything to your left, and sometimes, in fact, not feel the concept of a leftward direction. We know that there are certain aspects of the brain that will lead you to lose mathematics, morality, certain aspects of decision making, sensation, sensory motor coordination. And so you have in the brain a physical device that appears to play and to determine whether you can experience the consciousness of something or not. And that thing, the brain, is a necessary step to get consciousness, unless we eventually find a way to recreate those virtual networks in computers. But for now, it seems that consciousness is localized in the brain. Science can tell us that much, and it's modulable by activity in the brain, including the administration of drugs. So, separating the evolution question and the philosophical one, I say evolution answers the problem of how you could have consciousness to evolve without even necessarily being able to know what are the mechanisms of consciousness and how do I take a bunch of neurons and connect them in a way that leads to feelings. That is an answer that we may get in the future. I have no doubt that we will get it personally, but it really doesn't matter to evolution because it's a mechanistic question.
I would draw a distinction there between being able to explain why something might be advantageous and how something came to be. That evolution can contend that consciousness is, it has a utility to it, that it is useful for spreading your genes, and we could get into that as a problem as well, but that's not the same as explaining how it arose. And so if what we're trying to explain here is how human beings came to be, evolution can't explain how human beings came to be because human beings are conscious. It can't explain the existence of consciousness. Theism can explain the existence of consciousness. It has a greater explanatory power on this particular point. Now, if we get into other points as well, if we're getting into the biology of it, then perhaps evolution may have some stronger arguments. I have problems with those as well, particularly with the math. But with the issue of consciousness, that cannot be explained by evolution. You've conceded that point. You believe that evolution can explain it as being advantageous and why it would be passed on, but that doesn't explain how it arose. So there's no explanatory power in the evolutionary system with regard to consciousness, and that's necessary as a component of human beings. And so it's that explanatory power. It's why it's what I started with in my opening. If the system does not have the explanatory power to explain the existence of human beings, then it is inadequate. Evolution can't explain, it can explain some things perhaps. I don't deny all of what evolution says. I believe in microevolution, certainly. I have some issues with whether or not speciation works on the timescales that we have in play, because we only have 4 billion years on this planet, even if you're using the evolutionist timescale. Yes, I know it's 4.5, but it has to cool down. So the problem there is that you can't explain consciousness. You can't explain a human being. Maybe you can explain.
Well, you can't
very
either.
simple life.
At this point, no one can draw on a board and say this is why human beings feel the color red.
Because we have a
can
soul.
do the eyes, but we can't do the qualia or the feeling.
Well, as a theistic answer is very simple. We have a soul. We were created by God. God has given us self-awareness.
Well, and
so,
here,
no,
this is where
that
I
system
challenge your
has an
concept
explanation.
of explanatory. You could say, okay, I hereby say that God created everything and that God is the explanation to everything. There, I have an explanatory power of 100% onto the world, and yet I have zero insight into it. At least evolution gives us the beginning of an insight with the acknowledgement that we don't understand everything yet about biological creature. And yes, consciousness is one of the tough problems, but explanation does not only have to meet the criteria of being encompassed by the purported explanation, but the purported explanation must be provided alongside evidence that confirm it. That is the problem of the God explanation, which is it's an explanation with zero evidence.
I would disagree that the theistic explanation has no evidence, because as I already stated, in order for the system to be explainable, you have to have the amount of information necessary to describe the system. The universe being a system, you have to have the necessary amount of information to describe the universe. The only thing that can contain that is a significantly larger system, and on and on and on. It's the problem of the infinite regress. You have to go all the way back to an actual infinite. When you describe that infinite is God. And the reason that God has explanatory power, not just being the absolute infinite that can encompass the necessary amount of information for all systems to exist, but there is also the fact that this infinite has to be a personal agent, because it acted, because there was a start to the universe. Even if we take the 13.8 billion years, I don't necessarily disagree with that, because I think the universe is simultaneously old and not old. We don't need to get into that point now, though. I think it's sort of tangential what we're discussing. We agree that it had a beginning, and having a beginning is an act. Something has to do that. You cannot have an action from nothing. Nothing does not act. Something can act. And so the absolute infinite is what started the universe. So there is explanatory power there, and you can also create arguments in order to explain why God is the answer to these questions. And so I think the Christian answer, the theist answer, whichever way we want to categorize that, does have explanatory power as to why we exist, why the universe exists, and why it is the way that we find it. There are other ways that you can also build up to that. For instance, we all recognize that things aren't as they should be. Every human being looks at the world as we find it and goes, this is wrong. Things are not how they should be. Evolutionarily, that doesn't make any sense. That's not advantageous. There's no advantage to me thinking that there should be some perfect utopia. That's horrible. That's a terrible cognitive burden that is going to be detrimental. And in terms of consciousness supposedly being evolutionarily advantageous, if you're talking about total fertility rate, it's not. There are 20 quadrillion ants on this planet. There are only 8 billion humans. The ants are doing a lot better job of spreading their genetic material than we are. They don't have consciousness.
Maybe they do, maybe they don't, but they are, and that's no problem. Evolution has does not affirm that man is at the top of the living scale, and so it's no problem that we are outcompeted. And in fact, if a meteorite was to make it to the Earth and destroy big life like us, probably the bacteria would continue living and outcompete us. Going back to some of the premises that I challenge in your statements, I don't believe that an act beginning or that an event beginning, I would call it an event rather than an act, I don't believe that an event beginning and ending or not ending is indicative or necessitates a willful agent. Solar eclipses, for example, begin and end, and it is just a result of modular mathematics, circles, and the fact that planet Earth is revolving around the sun and there's a moon revolving around planet Earth. So, in mathematical systems that are absolutely not well, you have events beginning and ending, and the same could be true of the beginning of the universe. As far as information systems, I believe you have a fine understanding of informational and entropic concepts. I believe what you state is not exactly wrong. Yes, a system desiring to fully describe, and in other words, having omniscience onto a subsystem must be greater than that subsystem by definition, or at least equal if it is a perfect copy. Um, that there's still something missing in that assumption, which is you are assuming that because of this, you are assuming that the world needs a descriptor, that the world needs a mind to have it willed into existence. And that is fully assumed and not demonstrated. I agree with your statement about the limits of informational representation from the outside to subsystems. But I do not believe that all systems must be existing in the mind of an observer or an agent. Because even this begs the question, well, what about the mind of that agent? That mind would have had to have a certain degree of complexity. Where would be the information encoding that complexity? At some point, there needs to be a basic reality that is not necessarily represented in anyone's mind. And I believe that the universe in which we live might very well be it.
My specific contention is that the information necessary to describe a system is necessary for the existence of that system itself, and that the system cannot store the amount of information necessary to describe that system. So a system cannot exist without a larger containing system, which again is the infinite regress, leading back to the only possible solution, agreeing with Leibniz and many others, the absolute infinite, which is God. And I would agree with the classical formulation of God being absolutely philosophically simple, so there's no complexity there. That issue doesn't arise in classical Christian theology. I think that is the solution, explaining how there is anything. And to your point of there being solar eclipses and things like that, the issue there is that system was already set in motion. Those things occur because the larger system was set in motion. In that case, the solar system, the galaxy, the universe, these things were set in motion already. And so, of course, those are going to happen because they are inevitable as an outcome of the initial conditions, of the starting conditions of that system. But what we're dealing with when we go back to the beginning of everything, the beginning of the universe, is we're going from literally nothing to something. And we could just look at the basic laws of physics. An object at rest tends to stay at rest. Something has to act on it. There has to be an external force. There's no external force if you're going all the way back and there's nothing, unless there's a God. That's the only possible external force to put that in motion. But to some degree, I guess we're a little afield of the central part of the debate because we're sort of trying to explain human life. And I guess, yes, to explain human life, you do also kind of have to explain the fact that there's anything, life, the universe, matter, these things. But I don't think that evolutionarily we have an adequate explanation for the starting conditions necessary to build up to human life. And I don't think it explains human life either. Because as I mentioned, we have this problem of the digital problem, the second point that I mentioned. DNA is a digital representation. It is a digital code. It is the equivalent, biologically speaking, of an alphabet. And so, for instance, we are speaking English. We use an alphabet of 26 characters, give or take, depending if you have accents and things like that. They have meaning because we've assigned them that meaning. They have no inherent meaning. The same is true with regard to DNA. DNA has no inherent meaning. It has to be interpreted, as you of course well know, but for the audience, by a very complex system that reads and error corrects along the way, which is another interesting point. The system has error correction built in, but it has to interpret that DNA in order to use it to do things. The same as if we find words in a book, you need a mind in order to read those words to understand them, because it was a mind that made those words, that created that language. Many minds, in fact, in that case. But those symbols have no inherent meaning. They have assigned meaning, and that assignment of meaning requires an intelligence. The same thing is true with regard to DNA, and DNA is incredibly complex, particularly when we start looking at the numbers involved in this. An average book, a novel of relatively average length, at least historically, is about 50,000 words. That's pretty long. That takes a lot of effort, and as anyone knows who's written a book, but that is absolutely nothing compared to the human genome. When you're talking about 23 pairs of chromosomes and billions of base pairs, 3.2 in the haploid cell, 6.4 in the diploid, those numbers are basically unfathomable. Once you start running the math, there's no way, even if you have many individuals reproducing down various lines simultaneously, you still cannot, in the amount of time available, 4 billion years in this case, go from non-life to human life, even ignoring the other problems already addressed. Just simply mathematically, we don't have the time. I don't see a way for evolution to get over that hurdle, because just to give people an idea of the numbers we're dealing with here, if we use the simplest example, that 2,000 base pair virus, because that's sort of the easiest place to start to explain this, because the numbers for humans, again, we don't have names for those numbers. You're talking 10 to the 1024th attempts to get that 2,000 string. That's just the basic math of that. The universe is 10 to, it's 1.38 times 10 to the 10. Orders of magnitude more time is necessary to get the virus than the universe has been around. The largest number for which we have a name is centillion, which is 10 to the 303rd. Again, we don't even have names for the sort of numbers we're dealing with here, and we're dealing with the simplest thing that could possibly be considered life. For a human being, when you get up to billions of base pairs instead of 2,000, those numbers are incomprehensible to the human mind. Sure, we can write them down in scientific notation, but they have no real meaning to us because of how large they are. It simply can't happen according to the mechanism available to evolution. You have to have a starting point where there's already complexity in the system, and then from there, certainly you can have microevolution, you can even have potentially speciation through loss of information, but you're not going to get from bacteria or sludge or whatever it happens to be, you're not going to go from ocean life to land life to human beings. The time scale doesn't work.
There is plenty of time, and I brought some numbers here as a thought experiment. Of course, it's a raw model, but just to show how much time there is, there's actually extra time. So imagine you are a human being and you are making babies every 20 years. And your babies tend to have 150 mutations per generations, which is what we observe. We observe anywhere between 60 and 150. If you take 150 mutations every 20 years, and suppose that you are human beings making babies for 4 billion years, and we divide by the size of the approximate size of the DNA genome, which is 6 billion. Okay, yeah. Well, I have the calculation right here. So if you have 150 mutations per generations, and you have 20 years per generation, spread that over 4 billion years and divide by the total size of the human genome, approximately 6 billion. Of course, Mahler said 6.4. But you have approximately, in this raw model of a human being that would last 4 billion years, a chain of human being reproduction, you end up with approximately 5, which is the number of times each of your letter of DNA will have flipped to some other value. In other words, 4 billion years would be enough to completely redo your genome as a human being, where each of the letter has on average switch 5 times to some other value. It is plenty of time to build the human genome from scratch. Now, yes, it does have to start from smaller than the human genome. So that's where the raw model fails. This is not a representation of reality. The reality is we started with a much smaller genome. There may have been 50 base pair. There may have been less. Eventually, these molecules were subject to natural selection because they were making copies of themselves. And eventually, those molecules that find the most efficient way to make copies of themselves outlived and survived with respect to the other that were getting eliminated. It is very feasible mathematically over 4 billion years to move from an almost inexistent genome or a very, very small one to the one that we see in humanity. In fact, we have 5 times the time required to get there. Sometimes reality goes a little slower than theoretical mathematics. Now, as far as the beginning events and the natural selection that was happening then, very importantly, my theory of phenotypic revolution in the book, The Revolutionary Phenotype, lays out how you can have informational systems being selected. So what Mr. Mahler says here about information needs to be encoded, information needs to be understood, no, it doesn't. Information can also be subjected to the great filter of evolution, which is this system outcompeting other systems? And it just so turns out that sometimes a system of efficient communication and reliable symbolism outcompetes the systems of unreliable and chaotic symbolism. And it's what happened with life. We must believe from it that, yes, a system that is well organized outperforms, outcompetes the systems that are poorly organized. From that, you can get something that looks like symbolism and sense, but that is truly only obeying one rule, the rule of the survival of the fittest.
If it's obeying the rule of the survival of the fittest, then again, most other life forms on this planet, except for, of course, the ones we've wiped out, at least many of them, insects in particular, are much better than we are, evolutionarily speaking. Ants are superior to humans, termites are superior to humans, locusts are superior to humans. If we're simply looking at that, then your system, for one, is completely amoral, which you admit at the beginning of this debate, because morality is not really a concern for evolution. But why on earth would something like a human being arise? We're clearly not superior in any way. In fact, we're inferior in many ways. We are weaker than many animals. We are more vulnerable to many things, including certain diseases, many diseases, in fact. We have problems other animals do not have. Our reproduction cycle takes far longer, is far more dangerous for the female, has a significantly higher rate, not just for the female, but also for the children. We don't really have any advantages over many of the life forms on this planet. We shouldn't exist, evolutionarily speaking, and yet we do.
It's not that we shouldn't exist. All of the elements that you point out are true, but evolution does not optimize. As we say in biology, evolution does not optimize, evolution satisfies. We're alive because we're good enough to be alive. And it's not the case that we are in competition with all of the other life forms, because many of these other life forms live in other niches. They're not really competing for what humans are specialists of. And we are specialists of farming. We are specialists of enslavement of other life forms. And we are specialists in sucking the juice out of the baby embryos of other life forms, i.e. eggs. We are a vampiric kind of enslavement type of life form that in that niche, we are very dominant. I mean, there's no other species on Earth that has covered the planet with our fields and our chicken coops and our cows. And there's no other life form that has really so much cow farts that we're threatening our own existence.
I could bring up ants again because ants actually do farm, but leaving that aside, they actually do mostly,
They do.
and they do enslave other animals too, mostly
They do.
aphids. But
they're not as good as us. They don't have 1,000 types
No, we
of
have-
dog breed.
yes, we do have significantly higher level of and enslaving things that are more useful than aphids, certainly.
Yes.
Part of the problem here, I think, is a longitudinal problem, the generational issue. If you're speaking of beneficial mutations, many of these mutations that theoretically could be beneficial in the future are in and of themselves not beneficial at the time, not beneficial for the individual. In fact, in many cases, they are detrimental, but they could be beneficial at a species level or generationally speaking. And so, for instance, some of the things that benefit human beings, our intelligence, our planning abilities, our ability to cooperate with one another sometimes, these things are advantageous over a long period of time. But in the short run, they are not advantageous because, in fact, the person who simply runs around getting women pregnant and killing all of his competitors is, evolutionarily speaking, much more successful than either of us. Much more successful than anyone we would call a civilized human being. You don't have a way to make the jump from these slightly beneficial mutations in the long run to them actually being widespread in the population, because the individuals that have those are not going to be successful enough to outcompete those who don't have those mutations. We could give a particularly concrete example of this. Generally speaking, if you look at history and also today, Africans have a higher total fertility rate than Europeans. Africans, evolutionarily speaking, if we're simply talking about the core of evolution and ignoring moral concerns and everything else, Africans are superior to Europeans when it comes to simply reproducing. And in fact, the ones that are the best at it are the ones who are the most violent. So what is the advantage that we have, and how could that possibly arise? And evolutionarily speaking, should it even be preserved? I guess we're getting sort of into a moral issue there with a should, since we're dealing with ontology.
I think you're wishing your way into the consequences that you want. Because the fact is, we could be outcompeted by black people within the next 1,000 years. Until we know whether that happens, it's very premature to say, well, why do white people still exist? Well, they still exist because there was a time at which an intelligent and well-coordinated industrial society outcompeted this drive to breed. That time may be gone, and the time for white people may be done on this earth.
So the argument from evolution then would be that the only thing that matters is reproduction, essentially, because it's the propagation of your genes.
Well,
Everything
the only
else
thing
is
that
sort of
matters to evolution, that doesn't have to be the only thing that matters to you. As human beings, we can also make decisions about where we want evolution to be headed. We can wish a moral world. We can wish a world in which the murderer, the rapist, gets in prison and does not reproduce. And we can shape the evolutionary direction of our species. But ultimately, if we don't boil it down to, we have to stop the bad people to reproduce, and we have to help the good people to reproduce. If that doesn't boil down to this, eventually it disappears from existence. That is the rule of evolution.
Well, then we're getting into the sort of meta question that I had as my, I guess, fourth point, really. Why does any of this matter from an evolutionary perspective? Because you say we could, or maybe we want to, but that doesn't actually matter. Because truth doesn't matter in an evolutionary system. So in a very real way, the debate is kind of pointless if truth doesn't matter, because who cares what anyone believes? But in a purely materialist universe, there's no such thing as truth that is knowable. There may be truth, because again, there may be a correspondence theory of truth, but even that, I'm still relying on my senses and my thought. I'm relying on my ability to think. I'm relying on things that in your system were built up by evolution and therefore are inherently unreliable, because there is no objective foundation for them. The only thing against which they were tested is whether or not they provided some utility in passing on genes at some point in the past. And so I have no reason to trust any of my senses, really. I certainly don't have any reason to trust my mind in a purely materialist evolutionary universe. And so none of these things actually matter. There is no truth. There is no knowable truth, anyway. There's no good. There's no beauty. None of that means anything in an evolutionary framework.
I
And
believe
yet
that,
we know they exist.
well, to this, I would recommend adopting the view that truth does not need to be the fundamental property of your system for it to not be an emergent property of the system. And to tolerate the view of evolution and still be a moral being like I consider myself to be, you have to accept that morality and truth and our connection to the world, as you mentioned, coherentism, trusting our senses, that all of this can be emergent properties that come after. They are not necessary to evolution, but they happen to have happened. To someone who's black-pilled by the view of evolution, because there's no truth at the root of it, it's just a survival of the fittest mechanism. I will point out that this mechanism led to a whole lot of proper connection to the world in a way that what we experience from the world seems very much true. We don't have massive visual hallucinations. Some people are schizophrenics and they have some degree of visual hallucination, but even their hallucinations are connected very much to truth. We have a whole layer of neurons in the back of our eyes that are scanning the world at every moment and that are recording all of the shapes that we see, the colors, and we're accessing that information straight from the universe, which is to say, the genes could have gone in a way that is absolutely self-deceptive and chaotic, but they didn't go that way. The genes, to the contrary, have taken the path of very much being interested in recording a lot of information that is truthful about the world. And in fact, as far as our moral behavior, it has made us care a lot about what we do in society, about not hurting others. And all of it was advantageous to our reproduction. So don't despair because truth or morality is not at the root of this scientific explanation. It may be a result of it.
Physics professors are very fond of using the example of a perfectly spherical cow in a vacuum in order to remove a number of factors and complications on exams. I find that evolutionists like to use the word emergent when there's no actual explanation for what is happening in the system. And so I don't believe that you have these emergent properties. And one of the issues here is something that I've already raised. When you say it's an emergent property, or when you say that our senses are reliable, you're relying on those very senses in order to make that conclusion, in order to draw that out. If you say that, well, it's a physical system, and like we raised earlier with the color red, that's based on a physical reaction in the eye. Well, yes and no. It's based on that physical reaction in the eye because you have photons striking the cones, and then you have the processing in the brain. Well, the problem is it's that processing step. That's where we have no way in a materialist universe, in an evolutionary system, to say that that step is reliable. Because all that step has to be is useful. It has to have a utility with regard to passing on one's genes. There's no reason to conclude that it is reliable. You don't need reliability in this system. And so truth is utterly, absolutely unknowable. And yet truth matters very deeply to human beings. Why on earth would that arise? What I'm saying is that we find these things in reality. We find them within ourselves. We find that we understand goodness and beauty and truth. The transcendentals from philosophy, we have an explanation for those philosophically and theistically, but we don't have an explanation evolutionarily. There's no utility to them. There's no utility to understanding these things, to having them built into us. Evolution denies them utterly, and yet every human being on this planet recognizes they exist.
No, I believe that's not true. Those are false premises. I believe there were lots of gains into having morality or religious codes in terms of coordinating the society, and to the extent that coordinated human beings led to war machines that were more powerful and armies that were more powerful. Yes, religion, morality, good camaraderie were important things in winning the game of life. So no, I challenge this. And as far as emergent properties, okay, you can cancel the word emergent and simply acknowledge that there are causes. Evolution causes things, and selection leads to results in the world, and these results can be a moral ape.
To go back to a previous point, something that we discussed earlier with regard to mutations, I think we would be remiss if we didn't point out that most mutations are not only harmful but fatal. And so the issue of there being however many it is, somewhere between 50 and 150 mutations per generation, give or take, because those error correcting systems are actually pretty accurate. Of course, we're dealing with something slightly different. We're dealing with mutations because some of that is not necessarily an error, but it raises the issue of, say, chirality, of the fact that there are mirror image versions of certain molecules. And in fact, if something formulates the wrong one, typically that's going to be disadvantageous, if not fatal. Most mutations are going to destroy the organism and not be passed on. You're only going to have a tiny handful of them that can actually be passed on. That has to be factored into the math of whether or not these things are possible. Because, yes, of course, is 4.5 billion years enough time to randomly select a string of 4.5 billion or 3.2 or 6.4, whatever it happens to be, billion base pairs? Certainly. Just like we could do that with a computer right now and it'll spit it out in a second. This is sort of related to the issue of, say, password security. The length of your password and the complexity of the password are both important for how long it will take to crack your password. And it doesn't take very long to get to the point where it is essentially mathematically impossible, despite all of our advances in computing power. You only need a password that's maybe 32 characters long. It includes numbers, upper and lowercase letters, and symbols, and it's basically uncrackable. No one's ever getting in. And yet, when we're dealing with the genome, we're talking about billions of base pairs. And there are only a certain number of those strings, potential strings, a certain subset of them that are viable as human beings. And it's a tiny subset of them. I
That's
don't see a way
important.
for the it is absolutely very important. But
That's
I
an
don't think
important
it's
point because
advantageous to evolution.
my challenge to you is you don't know how many subsets of possible other genomes would have led to a functional being. When you look at the DNA from the perspective of password complexity, you're trying to get that single password that current humans are. But no one knows, in fact, not even scientists know, how many of the subsets of possible arrangements of DNA would have been viable. Maybe it's 50%, maybe it's 10%, maybe it's 0.001%. Until you know that number, any comment on the impossibility mathematically of reaching the one end result that we are is invalid because you don't have the statistics on how many of the intermediaries could have been viable salamanders or viable blobs of fat that would live under the sewers.
We do know that it's a very tiny subset. I won't give a percentage because, of course, we don't know, but we do know it's a tiny subset of those potential in the total space of the combinations regarding the human genome that would produce a human being. And we're trying to explain the existence of human beings. That's really, I think that's the core of what we're trying to do in the debate is say, how is it possible that we're having the debate? Like I said earlier, how is it possible that I exist, that you exist, that we're discussing this topic here and now? I don't think evolution is able to explain that mathematically. And I certainly don't think, again, there's no solution to that hard problem of consciousness. I know that you believe evolution will eventually explain it, will eventually explain those issues, but I don't think that it's possible. These
It's not
topics matter
exactly.
because they're core issues to explaining the existence of a human being, which is what we're trying to do. Why do I exist? I don't think evolution has an answer for that. If I were, you know, sludge of some kind in a pond somewhere, I wouldn't be asking the question. But in theory, if I could ask the question, maybe evolution would have a stronger argument for that. But all of those different problems that were listed earlier with regard to building up to human life, basically at every step, you can't answer it in a purely materialist framework. You have to resort to something else to have an explanation.
No, it's not
I do think
exactly what
evolution
I
has some
said.
power, obviously. Again, I do believe in microevolution. I certainly believe in that. I think that we all came from a single pair of ancestors, and notably, this is usually what evolutionists and biologists also agree. A species comes from a pair at some point in the past and then spreads from there. Different breeds, for instance, of dogs all come from some pair at some point in the past. I believe the same thing is true for humans. I just happen to believe the pair were Adam and Eve.
So I have not exactly stated what Mr. Mahler has stated here, that evolution would one day solve the hard problem of consciousness. To the contrary, I stated that the hard problem of consciousness is poorly framed, is erroneous, and is expecting something that is not a subject of science. What I do believe is that evolution already explains. You wouldn't have to face the hard problem of consciousness for evolution to be a complete explanation of everything that humans are, because we don't need a mechanical understanding of all the details of the brain and how this neuron connects to this neuron. But we can generally say that this arrangement of the brain must have outcompeted other arrangement of the brain, and that is it for the domain of explanation that evolution has to provide. On the question of the subset of possible mathematical arrangements of DNA that could lead to viable life, let us not forget that here you are saying that this subset is very small, but the entirety of life on Earth shows you various possibilities, and not even including everything that's alive today. We have to even include every fossil, everything that's ever existed. The diversity of life today shows you that the subset is not so small as people seem to think. In fact, the subset of different ways in which you can remodel DNA from being a squirrel to a whale are pretty amazing, and it's actually not so many differences. Not so many differences lead to the difference between a human being and a chimpanzee, between a squirrel and a rat, between to an extent between a bacteria and a starfish. So yes, the ensemble of possible life forms is impossible to evaluate at the moment, certainly bigger than everything you see on planet Earth that's currently alive.
I would agree that the possibility of the language of DNA is expansive. Because again, I believe it is a language, the same as not every book to be written in English or French or German has yet been written. Because the language has the capacity to express more than has been expressed. But that capacity is inherent in the language. I would contend the same is true of DNA. The reason the language has the capacity is because it was designed by human beings. I believe DNA was also designed. If I look at it, I see a language there. I see an alphabet that is used to construct meaningful sentences, passages, and books, to use the analogy of what we do with language. In this case, it happens to be sequences and genes and a genome. That's what we find when we actually look at biology, and it is more complex than what we do with language. It is much more impressive than any book that we have ever written. When we find something that bears all of the hallmarks of design, it doesn't make any sense to conclude that it is the result of random chance, even with the filtering of a selection against that random chance. And certainly, yes, the amount of life and the sort of vast differences of life on this planet is impressive, and I think that there could be more life than there is. The difference between us and a chimpanzee is what, 1.2%, something like that?
Mm-hmm.
I don't think that necessarily is a strong argument for evolution. I think it's an argument against evolution, because if we look at the example of language, if you slightly change a word, it's a totally different word. It could be a change of one character, and it's a totally different word. There are times where you look at sequences in human DNA, and if you change one base pair, you're no longer viable. There are things that you can destroy utterly by changing a handful of base pairs in a key point in a chromosome. In some ways, there is great variability, or at least possibility of variability, in the human genome, but there are other ways in which it is incredibly fixed and fragile. There are things that you cannot change, just like with the chirality issue. Those molecules have to be a certain image. And for those who don't know what we're talking about here, chirality just means there's a mirror image version of certain molecules. One is going to work biologically, the other is going to, at best, not work. It may kill you. That issue, and the fact that with regard to DNA, some areas cannot be changed whatsoever, I think draws out the analogy with language. And there's the example we could point out that a word, for instance, in English, gift, is a totally different word in German. It means poison in German. It's same word, same spelling, and everything. But that's because there was an intelligence that designed the system that is interpreting the symbols. And that system also matters. I am contending God designed that system, and that's why the system can interpret the language of DNA in order to create things like human beings and squirrels and chimpanzees. That information issue, I think, is insurmountable for evolution.
I think that you are jumping too quick to the conclusion of design without explaining why we see the traces of non-design. How do we even distinguish between an evolutionary system and one of design? Well, let's take language, as you suggested. Let's take books. Books are written. There are certain amounts of trial and error in the writing, but no one starts from a single word and starts shaking the letter and starts randomly arranging them and tries to pick up what looks like the best pages and eventually builds into a book. In other words, there is in design, there is a jump to the functional immediately. The first version, the first draft of a book represents pretty much what the author wanted to express with it, and that draft will undergo some degree of modification, but will not lead an array of ancestors, an array of draft ancestors that allow us to go back to the beginning of complexity and to single words. What we find on planet Earth is an array of ancestors that show that the book that humanity is, the book that our genome is, has not been written in a single shot. We have the trial and errors building up from extremely simple creatures like viruses up to extremely complex ones like apes and all mammals and eventually us. And for that reason, because we have the traces of the trial and error that was practiced, we can know for sure that even if a designer was to be involved in the planning and management of this physical universe we live in, certainly that manager used a process of evolution to get from simple complexity to bigger, to more complexity.
I think when we look at the world as we currently find it, we don't see an increase in complexity. If anything, over time, we see a degeneration. And a good example of that would perhaps be the breeds of dogs. In a way, each breed of dog is a degeneration from the previous kind of dog, from the progenitors of the entire dog species. And of course, we're talking about breeds, we're really talking about subspecies in some ways. The same thing when we talk about race for humans, it's really more of a subspecies. We just use different terms because they're considered polite. But what we really see is a degeneration from the previous example, because you could go from the original dog to all of the dogs we have today. You can't go from the dogs we have today back to the original dog because there was a loss of information in order to create those breeds. The same thing is true with regard to humans. Whatever our ancestors were, you can't get back to them from what we are today. And if you look at the accumulation of problems that we have, we don't seem to be getting better, which is what evolution should do because it should make us more fit. It should be selecting mutations that are advantageous in order to make us reproduce more effectively and more numerously. We're not doing that. We're collecting problems. We have greater health issues. We have fewer children. Things seem to be winding down. They seem to be degenerating over time instead of doing what evolution would predict. And Christianity explains exactly why that's happening. It's because of original sin. It's because the world is, in fact, degenerating over time. It is, in fact, falling apart. It is not getting better. We are not evolving into something new or better than our ancestors. We are, in fact, inferior to them because of the consequences of this world falling apart over time. That's what we seem to observe in reality. I don't see new species arising that are better than the things we currently have. I see us turning into something worse than those who came before us.
There are things that I agree with in what you stated. I believe that the irreversibility of time is not a feature of evolution, but it's a feature more broadly of all of physics. The entropic reality that we are in makes it so that you can shake die easily and throw them on the table, but to make them take their reverse path and jump back into your hand is much harder. So sometimes playing forward in the universe is all there is, and running backwards, although technically possible, is very unrealistic. And the same is true with the creation of subspecies. As far as degenerating, I don't. Evolution doesn't tell you that everything at all time will improve in will increase in complexity. To the contrary, everything must be equilibrated in evolution, and when there is not much complexity, if we look at life back 4 billion years ago, there must have been much simpler life forms on Earth. Then there was place for an expansion of complexity. There were niches that had not been discovered by these simple life forms, and more complex ones could arise. I would not deny that perhaps we are in a time of diminishment of complexity. Perhaps everything that's complex has been overly complex, just like the dinosaurs may have been due to die because they were too big and too costly. That is not a sign that evolution has stopped or that evolution is not true. To the contrary, it's that evolution doesn't have a preference. It doesn't have a preference for complexity. It can lead you there, but it can lead you in the opposite direction if the opposite direction is what favors more reproduction.
I think a fundamental problem we have with regard to what is being assumed about evolution is that it's being assumed. We assume that these systems work in a certain way, that they have done so throughout time immemorial back to the beginnings of this planet, and I don't see any evidence of it today. If these systems are working as it has been explained, they are working as evolution contends, whatever formulation, neo-Darwinian or whatever, we're just using the umbrella term. We should observe these things today. And as far as I can tell from looking at the world, we don't observe these things. We observe some phenotypical changes. Certainly, expression of genes can be turned on and off. Those things we certainly observe in successive generations. We do certainly observe some microevolution in terms of new dog breeds being created by mixing prior ones that already existed. But I don't see the acquisition of that which is new. And I know some will bring up certain bacteria. I saw pass by in the chat earlier that certain bacteria have, I believe the term that's used often is learned to eat plastic. But that was something that was already inherent in them. They had the information, it was turned on, which is interesting that they would have the ability to eat something that didn't exist. But I don't see this acquisition of new information and the creation of new species. I simply see a spreading out of types of subspecies under certain kinds of already existing species. We should see something new if evolution were true.
We see new features. We see new features appearing regularly. We see new species being born in the lab. Of course, people expect a change of kind and a change. Show me a chimpanzee transforming into a human. And the fact is that these events have been happening over thousands of years, and so they cannot be experienced in a single generation nor in a single life. That's where I say evolution is an intelligence test. Can you take all of the elements that you know to be true from current molecular biology, and can you extrapolate them? Can you look at how different a Down syndrome child is from another human? And can you think perhaps the first human was as different from its chimpanzee friends as a Down syndrome is to me? And can you realize that, in fact, the genetic defect that is happening in a Down syndrome child is very close to the genetic defect that led to the birth of humanity, in that it's a chromosome, it's an extra chromosome that finds itself at the wrong place. In the case of the birth of humanity and our distinguishing from the apes, it plugged itself in an inverted way to chromosome 2, probably led to a very fucked up looking first human, probably something that was looking absolutely disgusting and uninteresting. But somehow that was the recipe to, precisely have new genes. Because no matter how handicapped this thing was, that was the first human, it had another space on its chromosome 2 that could evolve in a different direction than the ones that was crystallized in the chimpanzee, which was stuck to evolve into the chimpanzee niche. And that thing had more space for mutation. You talk about novel mutations. There must have been novel mutations into this inverted chromosome 2 of humans, which we inherited from a dysfunctional chimpanzee chromosome. And that leaves space, that leaves novelty to be able to be selected, and that leads to mutations to be able to occur on a new segment that wasn't there before.
I think the example of Down syndrome is probably actually a fairly good one, because Down syndrome, of course, is an extra copy of chromosome 12. It's trisomy.
21.
Typically speaking, trisomy, right, 21. I was thinking 12 because I was thinking the inversion, which we have the example of the inversion of chromosome 12, which increases height, right. Trisomy 21 is Down syndrome. But I think the example is good because typically speaking, when you have an extra chromosome or are missing a chromosome, nothing good comes of it. And so this jump that we supposedly have argued for, which is the fusion of chimpanzee 2A and 2B, I believe it is, into what we have today for human beings, I don't think that would be beneficial, because if we look at the examples we have of that occurring in human beings or in animals, when you give an animal an extra chromosome or you take one away, typically the thing dies, or at least it is severely malformed. That is not evolutionarily advantageous. That thing is not going to reproduce. One, nothing else is going to want to reproduce with it. And two, it can't reproduce because it doesn't have the right number of chromosomes anymore to reproduce with the other members of its species. And if you're dealing with something like a great ape, or really any animal life, you're dealing with sexual reproduction. So there has to be compatibility with the haploid cells. You're not going to have that compatibility if it's missing a chromosome. You're going to have at least fundamental disorders.
It's not necessarily the case that it's incompatible. We don't know because we haven't created such a human. I'm a big fan of trying it, perhaps recreating a human from chimpanzee and seeing if it can breed either with current humans or chimpanzees. But given the repair mechanism that you know exists at the tip of chromosomes, it's very realistic to believe that in fact, a modified chromosome 2 was just perceived as longer by the system of meiosis, and that in the combination with an egg or a sperm that was not as long, simply a repair mechanism came in and reformulated the other side based on the template that it had of this longer chromosome 2, which was accidentally birthed that day. So no, I don't think that it's that you are reproductively incompatible just because you have different numbers of chromosomes. In fact, it keeps happening in plants. There are hybrids with various numbers of chromosome, and they reassemble themselves into third species, ring species. It keeps happening. So it's possible, first. Secondly, was it advantageous? And this is where the subtlety of evolution comes in. We must be careful. Was it advantageous? Was this creature more outperforming chimpanzees? Is not the right question to ask, because it may not even have been competing with chimpanzees. It may have been left to die on its own. It may have been ignored by its group of chimpanzees. It may have been regarded as a genetic defect that was certainly going to die. The only evolutionary criteria is satisfaction and not optimization. So you have to ask yourself, this blob of fat that the first human was, probably highly handicapped on many measures, did it have what it took to survive? Did it have what it took to eventually explore a different niche and survive in it? Was it enough for planet Earth? Yes, it was. And it led to the existence of today 6 billion humans that are the descendants of this original genetic defect.
The issue that arises there is the one that I raised earlier with regard to whether or not the mutation of this particular specimen is advantageous. You have the issue of whether it is advantageous to the individual there in time, and whether it is advantageous longitudinally to the species at some point, or a new species in this case, at some point in the future. The issue is jumping from that individual with the mutation to the mutation being widespread in the population. And in the case of something like this, some major mutation, you're not going to have that individual reproducing at a sufficient level to pass that on and wind up changing the species or creating a new species. For instance, we don't see a new species of human beings with Down syndrome being created. That's an evolution, if you want to call it that. It's a mutation, certainly. It is a defect, but we're not creating a new species out of it. There's no way to go from that one individual up to the species level, up to either a new species or changing the gene pool of the existing species, because that individual is most likely going to be reproductively unfit, not fit. It's not going to have an advantage. And so even if you're talking about it not competing, being in a different niche, it still needs reproductive partners. It has to have a way to pass those genes on. How is that going to happen with something that is fundamentally defective?
Well, that first human had the chimpanzees that were around it, presumably its own family, and perhaps had brothers and sisters and cousins that may have had different degrees of the genetic defect it had, or perhaps not. No matter what, their life finds a way. Ultimately, that is the sentence of Jurassic Park. As far as Down syndrome not creating their own species, personally, I'm very bullish on Down syndrome. I think that with medical advances, they may very well start their own club. And we've seen certain people start clubs of handicapped, people who are deaf get together. There is a community, and there's communities of people who are blind. And perhaps one day there's a community of Down syndrome people that decides to live separately and reproduce even separately from the main human line. And perhaps one day we enter into massive wars and somehow we spare the Down syndrome and they inherit the earth. That is the kind of story that could lead to a Down syndrome descendants for humanity without even a non-Down syndrome one. And this is the kind of evolutionary event that leads to the split of species.
typically speaking, what we would call that sort of bottleneck, which one of the terms we bottleneck for a species, and what would result from it would be inbreeding. And we know what happens with inbreeding, and it is nothing good. So if you have these consecutive bottlenecks in a species where you have a mutation that effectively is a jump, and therefore the individual is less compatible overall with the larger species and has a much smaller breeding pool, what you're doing is you're continually bringing these species back to a point of inbreeding. There's no way that is going to wind up creating creatures that have a reproductive advantage over time. In fact, it's going to do the exact opposite. Look at what happens with every species where inbreeding is a problem. I'm sure you're familiar with the genetic concept, what happens there. I've been involved in a number of zoological programs and dealt with things like that, where it is a huge concern for zoos today for certain species that we are trying to save from extinction because the gene pool has grown so small that they're almost non-viable now because we don't have enough breeding individuals to save the species. That's what happened to the northern white rhino. If you have these continual bottlenecks down through billions of years in this case, there's no way that is going to create anything good. It is going to do the exact opposite. You are going to destroy species. And so what you've done is you've taken the complexity you had in the past and destroyed it through successive genetic bottlenecks. It's another way in which the evolutionary mechanism doesn't work because it hits this roadblock. You can't explain how it jumps over this hurdle because it can't jump over that hurdle. We have the same problem with our backyard flocks of chickens and things like that. We see it in microcosm everywhere. And yet evolution supposedly relies on this working over billions of years.
Certain species crystallize, certain species don't have enough diversity and are faced with bottleneck problems. These species die. Just like 99% of the mutations are bad, 99% of the species are bad. And 99% of everything that lives ends up dying and not leaving descent. And so it is those unique species that have cultivated enough diversity and that have showed enough resilience to lead to subpopulations with various diversity in their various regions of their genomes. Those are the species that make it. And the mechanism for it are quite simple. Mutation, diversification, errors of copying, and replugging errors like happened to the first human to distinguish us from the chimpanzee. Those are not problems. Life faces those difficulties, solves it through the same mechanism that it solves everything else. Certain species don't cultivate enough diversity and they end up paying the price for it and don't exist anymore.
But if one of the mechanisms by which speciation occurs is this continual genetic bottlenecking, then you're going to have to surmount this particular problem of a too small gene pool theoretically millions of times. We don't even see it happening in the world today. If you take a backyard flock of chickens and keep having them breed with each other over 20 years, see what sort of outcome you have. It's not going to be good. You're going to have genetic defects. You're going to have morphological defects. You're going to have severe problems with your flock. This is a major concern for hatcheries, particularly now we have bird flu and many of the birds are dying or being culled. So if you have this happening today, how can you possibly conclude, and this is perhaps the IQ test that you raised, if you extrapolate backwards through time, the problems that we see, that we are able to demonstrate and say that you've had to surmount this millions of times, well, what you've just done is you've made it even harder mathematically for evolution to work. Because whereas before it only had to go in this sort of straight line from whatever the first life form was, which ignoring the jump there from non-life to life, but whatever that was to a human being, that straight line is certainly mathematically difficult, I think impossible, and I do think in the mathematical sense impossible. Now you have to do it successively every time you have this genetic bottleneck. Because what do you have to do with each bottleneck? You have to recreate the amount of diversity necessary to survive the next one, and then again to survive the next one. It's not going to work just in terms of pure mathematics. We know that from looking at
totally
the species
works.
today.
And I believe that the error you commit here is to mistake the scale of human farming with the scale of nature. There are simply massive populations, and you've said yourself about ants. There are massive amounts of ants out there. To think that bottlenecking is a problem for every life form and for evolution as a whole is to not even be able to approximate the amount of ants that are out there and that are each generating their own forms of diversity through their own mutation history. Bottlenecking is not a problem. It's a problem that humans see when they try to play with nature, but they try to do it at such a small scale that, yes, it becomes a problem if you're farming 10 ducks, 100 ducks, maybe 1,000 ducks. But it's not a problem for nature because there are just much more life forms out there generating much more diversity than can be handled by a single farmer.
2 points. The first is that, yes, you have these extremely large populations, particularly of things like ants, and I'll come back to ants. That's my second point. But the issue is you're creating this bottleneck. Because when you have a certain subset of the population that has this mutation that needs to be, in the terms we're using here, needs to be, not in the moral terms, but needs to be passed on to the next generation and the next generation in order to create this new species. In order for speciation to occur, you have this inherent and necessary bottlenecking of the population. And so the entire population is not involved. It's only those submembers of the population that are involved in passing on these genes to create the new population. So there is a continual bottlenecking going on. And again, with ants, I think they're a great example because, again, 20 quadrillion ants on this planet, and they're all still ants. We see many kinds of ants. We see leafcutter ants, we see fire ants, we see black ants everywhere, bullet ants, all sorts of types of ants. But they're all still ants. Massive opportunity for evolution to create some new species out of ants because you have all of these diverse populations spread all over the world, very, very many of them, and yet they're all still ants. Supposedly millions of years of them being ants, evolutionarily speaking. We don't see any new species coming out of that. We just see a lot more ants.
Bottlenecking is not a problem, among other reasons, because the reproductive isolation that happens in speciation happens over a long period of time. And it's not true that once a gene shows up, you need to isolate that gene from the whole population to create a new species. What's happening is there are many genes that show up and they are being exchanged precisely because of sexual reassortment. So because of sexual reassortment, the gene makes its way through the population that hasn't yet undergone the process of speciation. And you have probabilistically certain genes make it in the whole of the population, certain genes make it only in half or only in a quarter. And it depends on how much additive value they provide to the fitness of the individual. But eventually, when speciation happens, there is already a distributed set of genes. Some of them make their way in one direction more than another, and that's where you get a bottleneck effect on those genes, when in fact these individuals that form the birthing species are still reproductively compatible with the individuals of the previous one, and in fact will still integrate some amount of reproduction with the older, more ancient species. And it's only after millions of years of reproductive isolation that presumably they become totally reproductively incompatible. So there is a detachment that is progressive that is not fully captured by what you describe as the problem of bottlenecks. That will be my comment on this. Now, I think we've gone around a lot of everything pretty much that I had to say. I don't know if you had anything else to bring before we head to the chats or conclusion.
I think we've covered pretty much everything that I had to say at this point. So,
all right.
Okay, well, my brain is only hurting a little bit from trying to follow along with all of that. In terms of the super chats, there really wasn't that. It was mostly just either people saying thank you. We'll go through some real quick here, but there wasn't a lot of questions, so this shouldn't take long at all. Basin Butterfly Pilled said, two of my favorite minds alive today. Thank you for putting this together. I'm not reading that one. TK says, but thank you, Ice Mexican. TK sent $10. He said, more Corey is exactly what I need to power through this shift. Been in overtime since 9 this morning. Okay, thank you for that. Man, I'm just skipping through some. Don Browning sent four $2 super chats. Thank you for those. There's no questions. Ochibana sent $2. Kino Casino, thank you. Gulf City the Librarian sent $5. We already have a community of Downies breeding outside humanity. We call them North Sentinelese.
I did see that one go by.
And let me check the power chats real quick. So we're going to be wrapping this up right away. So if you have a question you'd like to get in, send it now, because we're probably going to be done in a couple minutes here. Mark Beamer sent $20. Thank you for hosting this debate. Always love hearing from Mahler, and JF was a great guest too. I think that's it. I think that is just double checking entropy and everything. Yeah. Okay, well, that's it. So that was awesome. Like I said, it was a little bit, it was a little bit too much brain power for me. I'm going to have to rewatch it again later and try to follow along. But I really enjoyed it. I want to give a big thank you to both our guests for showing up today. Why don't you guys, before we go, you can plug your channel or let people know where to find you or whatever. Corey, why don't you go first?
I'm fairly easy to find. My website is just my name, CoreyJMahler.com. The podcast that was mentioned in the intro is where most people probably know me from. That is the Stone Choir podcast, stone-choir.com. And other than that, I can be found on X until I get banned again. So
I'm on X, and you can find all of my links at jfg.world. I've now moved to Rumble for the video and X for the writings. So at jfg.world.
Okay, we did have one question come in here for JF from Bliss Chilling. He says, what evidence would convince you that evolution in the terms you hold is incorrect?
There would have to be a document appearing in intergalactic space which would state, I've been written by God, and I would be able to verify that no humans may have seeded that document falsely, and it would contain the whole description of how God tricked me into thinking that I was in a universe with evolution, and it would reveal all of its tricks and how that he has done to fool me.
In fairness, that document does exist because technically we're on Earth in intergalactic space. And it's called the Bible, and Genesis explains it. So technically it's there. And there is very good evidence that the Bible was not created just by men. It was written
but there
by
would
men
have to be in the
God.
document, there would have to be something that I can use that is showing me that the person who wrote it has supernatural powers.
I would say that the Bible clearly demonstrates that, given the number of interconnections and references back and forward in time in the Bible over a span of centuries written by many different men. Human beings are not capable of doing that by themselves. We can barely manage to write 3 or 4 books in a series and keep our own story coherent.
Cool. All right. We got a few more super chats coming in, but it was mostly just people saying thank you. So thank you everybody for that. Appreciate it.
Don't lie, I hypocrite. It was mostly people insulting me, I'm sure.
No. There was a couple at the start.
These accusing me of being a murderer. Unbelievable, people of the internet.
Well, since you bring it up, there was one that said there was one at the start that said, I don't think we should associate when there's compelling evidence that this guy killed his wife or whatever. And my answer to that would be that whatever evidence there is has been examined by the police, and it wasn't compelling enough to them to decide to press charges, and they've probably seen more and know more than I do. So I'm going to remain agnostic on the question.
You're agnostic about whether I murdered someone. Unbelievable. I would expect a little more.
It depends.
Oh yeah, you are an attorney, right?
Yes.
All right, everybody. Well,
so technically, after he leaves, you can confess to me, and then I can't ever tell anyone because of attorney-client privilege. So.
Okay, we did have a question come in there. Somebody wants to know what your email is, Corey.
The best email would be the feedback address for Stone Choir, feedback@stonechoir.com. stone-choir.com, to be clear. Or on X, although, quite frankly, if you DM me on X, it may be a while before I see it because I have thousands upon thousands of pending message requests on X. So, yeah, the email may be a little better. We'll see how quickly I respond to that.
There's a lot of spam on X too.
There's a ton.
Austin sent $5. He says, do you believe AI will solve human consciousness?
It will not solve it. It will replace it. It will encompass it and be able to produce it and create fake forms of it and eventually replace all of us. That is the subject of the theory of phenotypic revolutions.
I am certainly not a fan of AI, as many people already know. I've written a couple of articles on it. I do think that it poses some serious problems. I don't think that AI can rise to the level of being actually self-aware, of being sentient. I think that Cyril's Chinese room experiment proves that relatively conclusively. I think there are other arguments for it as well. Some of those are kind of high-level philosophical arguments that are perhaps gone into it better length and better depth elsewhere. But I do think that AI poses a threat to humanity. I don't think that all of the threats are necessarily what people generally associate with AI, but I don't think it's something that we should be pursuing as foolishly and wholeheartedly as we currently are.
Absolutely.
All right. Okay, well, that's the stream then. Again, big thank you to the guests. Thanks to everybody for watching and all the people sending the super chats. Really appreciate the support. Hopefully we'll get to do another one of these sometime. You guys all enjoy your rest of your day, your weekend, all that, and we will catch you later. Bye. Wait, I don't have the outro on here anymore. All right, well,